Let's continue talking about the carboxylic acid derivatives. The next derivative that we're going to talk about is the amide. And when we started this, we made a list of the reactivity of all of the carboxylic acid derivatives, and the amide was last on the list, which means that it has the fewest number of reactions out of all of the derivatives. We're going to start by how to make the amide. There are quite a few different ways to make an amide, but the simplest way, and the way that your book uses, is to take an acid chloride and just do the aminolysis reaction with whatever amine you're trying to make. Remember, that's going to be, we need excess of that or 2 of that. And so depending on which amine you use for this reaction, you can end up with a variety of different amides. So there's that. As far as the reactions of the amides, they only do 3. Really, they only do 2. We can do hydrolysis, either acid catalyzed or base catalyzed. The hydrolysis reaction is between the amide, and I'm going to write it using NH2, but it could be a substituted nitrogen as well. So there could be 1 or 2 R groups on the nitrogen. Acid catalyzed means that we're doing this with H3O+. This reaction does require us to give it a little bit of heat, and it turns the amide into a carboxylic acid. And similar reaction, we have the base catalyzed hydrolysis. Both of these, the acid and the base catalyzed reactions, are giving us the same product. So you would have the flexibility to choose either the acidic reagent or the basic reagent, depending on what was most appropriate for the other functional groups that you had on your molecule. So this, we use hydroxide because it's base catalyzed with a little bit of heat. And the initial product that we get after this, we do get the carboxylic acid product, but because we have this hydroxide, which is a strong base, it is going to deprotonate our carboxylic acid, makes it a carboxylate. And so to put it back to a carboxylic acid, we need a step 2 with H3O+, or even probably just with some water, to reprotonate and give us a carboxylic acid. And for both of these reactions, if you're curious about looking at the mechanism, it's nothing tricky. It's the same type of mechanisms that we've been looking at in all the reactions in chapter 21. The mechanism is around page 1022, 1023, depending on which edition you're using. You should be able to find it, no problem. The last reaction of an amide is a reduction reaction. And this uses our strong reducing agent, lithium aluminum hydride. We need excess of that reducing agent. And it is going to reduce our amide to an amine. Don't lose that carbonyl carbon. And that's it. That's all that we have for the reactions of the amides. So they don't do the other reactions that we've seen, like alcoholysis or different types of reduction reactions, or reacting with Grignards or anything like that. So that makes this section pretty nice and short.